Hello there, welcome to CXC Math TV. Today we will be looking at quadratics. Now, under quadratics there are many objectives under the Csec mathematics syllabus, so we want to look at complete the square for any quadratic equation. We want to be able to determine the maximum and the minimum points of quadratic functions, and we want to be able to sketch quadratic functions. That's what we want to do. So first, consider this function. F of x is equal to x squared minus 7x plus 6. Find the roots of the function of f of x. Now, we already know that roots are the values of x when f of x is equal to 0. So some persons like to call it the x-axis intercepts. So to find the roots, we can either use a quadratic formula or by factorization. Let's do it by factorization. So we have x squared minus 7x plus 6 equals 0. So we ask ourselves which two numbers, when we multiply them we get 6, when we add them we get negative 7. So we split the middle term minus 7x as minus x minus 6x. And then we factor out from the x squared minus x minus 6x plus 6, we factor out x. We're left back with x minus 1. And from the negative 6x plus 1, we factor out negative 6, and we're left back with x minus 1. So the expression x squared minus 7x plus 6 can be written as x minus 1 times x minus 6. When we equate that to 0, what we're getting then is either x minus 1 is 0 or x minus 6 is 0. And so finally we can say that x is equal to 1 or x equals 6. So those are the two roots of this quadratic equation. So the roots of the equation are 1 and 6. Now if you were to plot the graph of f of x is x squared minus 7x plus 6. So all we're going to do is substitute x values in f of x to find their corresponding y values. When we plug in negative 1 in f of x, we get 14. When we plug in 0, we get 6. When we plug in 1, we get 0. When we plug in 2, we get negative 4. When we plug in 3, we get negative 6. When we plug in 4, we get negative 6. When we plug in 5, we get negative 4. And when we plug in 6, we get 0. When we draw that curve, and we draw the curve, this is what we're getting. Beautiful. As we get that curve right there, we can see the roots are x being 1 and 6, where it cuts the x-axis. Beautiful. Now, did you observe anything? And what if I were to ask you, what is the minimum point of f of x? Now, if you were to observe, we're going to put a red point on the graph. That red point on the graph right there is the minimum point. That red point right there would be the lowest point on the graph. If you're to look at that point right there, point A, the minimum point of our quadratic function in Symbolab is 3.5, negative 6.25. From our sketch, you can see it's roughly the same. In between the 3 and the 4 is 3.5, and the y value is negative 6.25. Nice. So, do you think there is a formula that we can use to find what that minimum point is? Now we're going to connect what we just observed with just a general quadratic graph to learning some new stuff now about quadratics. Hey! So the standard form of a quadratic is written in the form ax squared plus bx plus c, where a is the coefficient of x squared, b is the coefficient of x, and c is your constant. A quadratic graph, it has a parabolic shape. What do we mean by parabolic? It just means that it either smiles or it's going to frown. That's an easy way to remember it for now. Now, when f of x is equal to ax squared plus bx plus c, and a is greater than 0, then the function is going to smile. F of x smiles. Example, f of x equal x squared minus 7x plus 6. We just plotted that graph and we found that the roots were 1 and 6 and that the y-axis intercept was 6. So it looked like this. So the graph smiles. The graph smiles because the coefficient of x squared, which is a, is greater than 0. Alright, so remember, this was the graph. So a is greater than 0, so we smile. Once the x squared term is positive, the coefficient of it is positive, we smile. We love positive numbers. Whenever f of x is equal to ax squared plus bx plus c, and a is less than 0, the function is going to frown. So when a is less than 0, the function is going to frown. Aww. So for example, f of x equal negative 3x squared minus 5x plus 7. If we observe that graph, we don't know where the roots are, but we just know that the y-axis intercept would be 7, and a would be negative 3, b would be negative 5, c is 7. But a is less than 0, so the graph frowns. So in a case like this, when a is negative, it frowns. So it frowns, alright? Once a is less than 0, it frowns. Alright, so what I want you to do is to pause the video and state if the function is going to smile or frown. Alright, so the first one, f of x is 5x squared minus 6x plus 2. That is going to smile. That's because a is 5, b is negative 6, c is 2. So the coefficient of x squared is greater than 0. Nice, so that one smiles. The second one, g of x, 3 plus 6x minus 2x squared. The first thing you have to do is rewrite it in its standard form. So put it as minus 2x squared plus 6x plus 3. We have to write it in descending powers of x. Alright, so we start with our x squared term. So the a is going to be negative 2, and so a is less than 0, and so a is negative, so g of x frowns. H of x, we do the same. We put it in standard form. Minus 4x squared plus 5x plus 6. A is negative 4. B is 5. C is 6. And so a is less than 0. And so h of x frowns. Hey! What about the last one? Q of x. 7 minus 2x plus 4x squared. Again, put it in standard form. So it's going to be 4x squared minus 2x plus 7. A is 4. B is negative 2, C is 7. So A is greater than 0. So Q of x smiles. Hey! And so that would be the shape of each of those quadratics. Alright. Now that we've identified the shape of each quadratic, the next thing we want to talk about is the vertex form of a quadratic equation. Now, any quadratic equation, f of x equal ax squared plus bx plus c, as we call it the standard form, it can be rewritten in the form a in bracket x plus h squared plus k, where k is just some constant to be determined. So for example, look at this right here. What if I were to give you a function f of x equal to x plus 3 all squared minus 7? We know that x plus 3 all squared would mean that we're multiplying x plus 3 times x plus 3, and then we subtract 7. Expanding the bracket, we get x times x plus 3 plus 3 times x plus 3, and then we subtract 7. We continue when we expand, we get x squared plus 3x plus 3x plus 9 minus 7. Now the 3x and the 3x is 6x, and the 9 minus the 7 is 2. So that's x squared plus 6x plus 2. So look at that. Notice that f of x is equal to x plus 3 all squared minus 7, and f of x is also x squared plus 6x plus 2. And so, the f of x being x plus 3 all squared minus 7, that's known as the vertex form of the quadratic. And the x squared plus 6x plus 2, that's known as the standard form of a quadratic. Hey! As you can see, it would be easy to go from the vertex form to the standard form. Like what we did previously, all we did was expand the brackets to go from vertex to standard. So how do you go ahead and convert from standard form to vertex? Now, in order to rewrite a quadratic function from standard form to vertex form, which is rewriting in the form a in bracket x plus h squared plus k, the constants are computed by the formula. H is equal to b over 2a, and k is equal to 4ac minus b squared over 4a. And so, let's look at this example here. F of x equals 3x squared plus 7x plus 5. rewrite in the vertex form. First thing we do is write down a, which is the coefficient of x squared, which is 3, b is 7, c is 5. H is going to then be computed by b over 2a. So it's 7 over 2 times 3, which is 7 over 6. K is going to be computed by 4ac minus b squared over 4a. So k is going to be 4 times 3 times 5 minus 7 squared over 4 times 3. And then that works out to be 60 minus 49 over 12, which is 11 over 12. And so we're going to replace h with 7 over 6 and k with 11 over 6. Replace a with 3. So that is f of x in vertex form. Alright, so f of x is 3 in bracket x plus 7 over 6 square plus 11 over 12. That's f of x in vertex form. So pause the video and rewrite this function in vertex form. 10 plus x minus 2x squared. As you pause and rewrite in vertex form, remember the first thing we need to do is rewrite it in standard form. So f of x is going to be minus 2x squared plus x plus 10. So a is going to be minus 2, b is going to be 1, and c is 10. So now h is b over 2a. So it's 1 over 2 times negative 2, which is equal to 1 over negative 4, which is negative a quarter. K is going to be 4 times a times c minus b squared over 4a. So we substitute a, c, and b. A as negative 2, c as 10, and b as negative 1. Inputting all of that into our calculator, k is 81 over 8. And so f of x is going to be a, which is minus 2 in bracket x minus a quarter square plus 81 over 8. That's because our h is negative a quarter and our k is 81 over 8. Now, how does these h and k impact the graph? What do they do? What are their purpose in the graph? Well, if we go back to the first example, in the first example we were looking at, remember when f of x was ax squared plus bx plus c, and we said, what about the function f of x being x squared minus 7x plus 6? We said that the graph smile. And remember we found the roots, and the roots were 1 and 6. Go back to the start of the video. And remember we said the y-axis intercept was 6. Remember we also said that the minimum point was 3.5, negative 6.25. Since we said all of these, let's look at something here. Work out the value of h. H is going to be b over 2a, which is negative 7 over 2 times 1, which is negative 7 over 2, which is negative 3.5. K is going to be 4ac minus b squared over 4a. And when you input a, b, and c with their respective values, it works out to be 24 minus 49 over 4, which is negative 25 over 4, or negative 6.25. Now, did you observe anything? So what we can conclude then is what we observe is any function f of x, when it is written in the form a in bracket x plus 8 squared plus k, when a is greater than 0, the function is going to smile. When the function smiles, the function is going to have a minimum point. And the minimum point is going to be negative hk. This is instrumental in allowing us to sketch the graph of the function. So that's observation 1. C is going to be the y-axis intercept. The minimum value of f of x is going to be k, and the value of x, the minimum occur, is negative 8. So looking at the graph right there, as you can see, when f of x, when a is greater than 0, the function is smiling. And once the function is smiling, it's going to have a minimum point. The minimum point is minus hk. And we can see the y-axis intercept is still c. We can also see that the value, the minimum value of the function, that y value is k, and the value of x, the minimum occur, that's negative h. When f of x is equal to ax squared plus bx plus c, whenever that function is written in vertex form again and a is less than 0, the function frowns and it's going to have a maximum point. The maximum point is still going to be minus hk. C is still going to be the y-axis intercept, but now the maximum value of f of x is k, and the value of x, the maximum occur, is negative h. So the only difference between observation 1 and observation 2 is whenever a is less than 0, this time the function is going to frown. And the maximum point is going to be negative hk. The value, the maximum value, that's going to be k. The value of x, the maximum occurs negative h. So now that we have all of this right here, how are we going to utilize this in some exam style question? So now we're going to look at some exam style question. So look at this question here now. Given the function f of x is 2x squared minus x minus 15, rewrite the function f of x in the form a in bracket x plus 8 squared plus k, where k and h are real numbers. Part B, state the minimum value of f of x. Part C, state the values of x for which the minimum of f of x occur. Part D, what are the roots of f of x? Part E, sketch the graph of f of x. Now, as we're going to do this question right here, the first thing we need to do is to rewrite it in vertex form. That's all they're saying for part A. So what we're going to do is write down our A, or A is 2, or B is minus 1, or C is negative 15. And so H being B over 2A is going to be negative 1 over 2 times 2, that's negative a quarter. Now K is going to be 4AC minus B squared over 4A. That works out to be 4 times 2 times negative 15 minus negative 1 squared over 4 times 2. Put that in the calculator, that's negative 121 over 8. But remember, f of x is a in bracket x plus 8 squared plus k. Now that we found h, replace h with negative a quarter. And once we found k, replace k with negative 121 over 8. And a is 2. So that's all. So now we can write f of x is 2 in bracket x minus a quarter square minus 121 over 8. The next part, state the minimum value of f of x. The minimum value of f of x is always equal to k. What was k? Negative 121 over 8. So that's your minimum value, negative 121 over 8. The next part says state the value of x for which the minimum occurs. The value of x, the minimum occurs, is always negative h. Negative h. So it's going to be negative of negative a quarter, which is positive a quarter. So that's positive a quarter. And that completes A, B, and C. Part D now says, what are the roots of f of x? Now remember, roots occur when we solve the function f of x equal to 0. So we're going to solve the quadratic equation equal to 0. And in order to solve the equation, we know that we need to split the middle term. So the minus x right there, we're going to break it up as minus 6x plus 5x. So now we can write 2x squared minus 6x plus 5x minus 15 equals 0. So we factor out 2x. So we have 2x in bracket x minus 3. From the next two terms we factor out 5. We have 5 in bracket x minus 3. So this simplifies to be 2x plus 5 times x minus 3 equal to 0. So it's either the 2x plus 5 is 0 or the x minus 3 is 0. From that we get x is negative 5 over 2 or x is 3. So the roots are negative 5 over 2 and 3. Now, part E is going to ask us to sketch the graph of f of x. So now to sketch the graph of f of x, we have all the information we want. So what I like to do first is draw my x and my y-axis. Start with the minimum point. The minimum point is a quarter, negative 121 over 8. Once I do that, I like to then just draw my curve. I know that my curve is going to smile since it is greater than 0. A is 2. So I know it smiles. So I draw my smile. Now I put on my y-axis intercept, which is negative 15. I then put on my roots, negative 5 over 2 and 3. Alright, and that represents the graph of f of x being 2x squared minus x minus 15 equal to 0. Alright, so just to give you one more to close out the day to attempt on your own, go ahead and pause the video and attempt this on your own. Go ahead and pause the video and attempt this one. It says, rewrite the function g of x in the form a in bracket x plus h squared plus k, where h and k are real number. Then we want it to state the maximum point of g of x, then find what are the roots of g of x, and then sketch the graph of g of x. Go ahead and attempt this question. Alright, as you pause and attempt this one, we all know what we should do. Put it in standard form first. So we rewrite g of x as negative x squared minus x plus 7. And we write down our a, b, and c. Once we write down a, b, and c, a is negative 1, b is negative 1, c is 7. We then use the formula h is b over 2a. So it's negative 1 over 2 times negative 1, which is a half. And then we use the formula for k and input a, b, and c as their respective values. Put that into the calculator, so k is 29 over 4. So now f of x is a in bracket x plus h squared plus k. Remember, a is negative 1, h is a half, and k is 29 over 4. So in that case, f of x is negative 1 in bracket x plus a half square plus 29 over 4. That's part A. Now part B said state the maximum point of g of x. Remember, the maximum point is negative hk. So we just write negative a half 29 over 4. When it asks you for the point, you have to put the x and the y coordinate. You have to put the x and the y coordinate. When they ask you for the maximum value, you will just give them the k. When they ask you for the minimum value, when they ask you for the maximum or the minimum value, you give them k. When they ask you for the value of x, the maximum or minimum occur, you give them negative h. But when they ask you for the maximum point, you give them the x and the y coordinate. Okay. Now, in order to find the roots, what we observe quickly is that this quadratic, it doesn't seem like we'll be able to factorize it. So we're going to have to go back to the quadratic formula. So remember, a is minus 1, b is minus 1, and c is 7. So we're going to use the quadratic formula. X is minus b plus or minus the square root of b squared minus 4ac over 2a. We're going to input b as negative 1, a as negative 1, and c as 7. We'll put that in the quadratic formula. We'll get 1 plus or minus the square root of 29 over negative 2. So the two x values are 1 plus root 29 over negative 2, or 1 minus root 29 over negative 2. So that works out to be negative 3.19 or 2.19. And so now we're able to sketch our graph. So I like to start with my x and my y-axis. Then I put on my maximum point in this case, the negative a half 29 over 4. Then I just draw a curve, make sure it is parabolic in shape, meaning it frowns evenly going down. And then I put on my y-axis intercept, which is 7, and I put on the roots, negative 3.12, negative 3.19, and 2.19. And that would be my g of x right there. Nice, 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 nice. And so that completes quadratics. That's all you need to know in quadratics. Remember, you need to know to complete the square. You need to be able to identify maximum or minimum point, and you need to be able to sketch the graph. And so stay tuned to CXC Maths TV. That's it for today. Make sure to keep on practicing. Practice lots more questions. You can utilize the symbol lab to help you to check your graph to make sure it's correct. A link is left in the description. Have a blessed day.